organized class to record on. So today what we're going to do is we're going to solve quadratic equations. So it's just more quadratics, okay? So thus far we've looked at graphing quadratics. We've graphed with a table, and we've learned how to do the x equals negative b over 2a part, right? The solving quadratics is going to bring in factoring again. Factoring comes back to us. And remember when you did the getting ready for chapter 9? The very last question is zero product property. What does this mean to you? Today we're going to learn what the zero product property actually is and how we're going to actually use it. This is a pretty exciting day. I'm not feeling super well, so I'm kind of being quiet. But this is a really big deal. I'm not even lying. It brings a bunch of stuff together, and I love this stuff. I love solving quadratic functions like this. So it's a good day. It's a good day. This will just make your week complete, really. It will. I promise. And if it doesn't, I don't know. I'll cry. I'll weep for you later. Weep. I'll weep for you. So there's multiple ways to solve quadratic equations. Today we're gonna use two methods. We're gonna solve by graphing and we're also gonna solve, they call it the square roots, and you'll see what we mean. So there's a couple ways to do this. Today we're gonna learn about these two ways. Okay? We can also, later we'll learn how to do it with factoring. We'll also learn this wonderful thing called the quadratic formula. This is exciting days ahead of you. I don't think you understand. Math is about to just be crazy awesome. Okay, so once again, we're going to bring this back. Key concept. Standard form of a quadratic. STD is standard. That's an abbreviation for it. This is standard form. ax squared plus bx plus c. And we're doing equations. So equations have to have an equal sign. So this is what we're going to be looking at today. So instead of equaling y, what's it equal now? 0. And remember when you guys were doing section 32 in the computer, and you had to take the equation, equal a number, and the first thing you had to do was move the number over so it equaled 0? Same thing here. We need these to equal 0 when we start. Okay? Graphically, I'm going to take the one that we just did on the homework, okay? Graphically, these solutions are where the graph crosses the x-axis, because we want to know when it equals 0, right? So this right here is when y equals 0. This whole entire line is where y equals 0. So when we have an equation, when I want to know when it equals 0, I'm going to look where it crosses the x-axis. So it crossed right there, and it crossed right there. Graphically, those are the solutions to this equation. It's where the graph crosses the x-axis. Okay? Okay, it's about to get real up in here. So, up in here, about to get real. So here's what I'd like you to write. Graphically, write this down, please. Write this down. Graphically, the solutions are where the graph crosses the x-axis. Okay? So graphically, it's where the graph crosses the x-axis. Write this down on your notes. Not on my graph paper. Thank you. The places where things cross on the x-axis, these are called the X-Intercepts. It's where it crosses the x-axis. X-intercepts, a lot of times these solutions will also be called too as roots or zeros. These are all saying the exact same thing. They all mean the same thing. You're finding out when the function equals 0. If you want to find the roots, you want to know where it equals 0. You want to find this, the zeros, it's where the thing equals 0. The x-intercept, graphically, that's where the equation equals 0. All these things mean equal 0. Find what makes them equal 0. And it's super awesome. No joke. Okay. Yes. Use the pass. All right. Zeros, yes. Yes.
So we make it equal 0 than we did what we learned yesterday?
We can, yeah. To graph it, to do it graphically, exactly. Is that okay? Okay. So we're going to do some examples, and I really need some sticky notes. Don't worry, I have some. Don't panic. I can tell you guys are getting upset about it. Okay, so example 1. We need to find the solutions using the graph. They really helped us out here on this one. We don't even have to graph. They graphed it for us, which was super nice. Super nice. So we want to see where it crosses the x-axis. Nick, put it away, please. Put it away, please. So graphically, when we look at this, we're looking for where it crosses the x-axis. So what x makes this true? X equals, what is that? -1, and x equals 1. So how many solutions does this one have? How many times did it cross the x-axis? It crossed it twice, so how many solutions do we have? We have 2 answers that make this true. What about this one? How many times does this one cross? Just 1, and that's when x equals 0. So this only has 1 solution. What about this? It didn't cross at all, so is there any solution? No! It did not cross the x-axis. There is no x that will make that equal to 0, because it won't ever touch it.
So when you ask me a question like this, and it comes up like that, I just say no solution.
You say no solution. Yes. Okay, so let's do some where we actually find the graph and do all this stuff. Okay. Oh. Okay. So here we go. Now we're going to do some now. Ready? So write down example 1. And let's graph this guy.
Still kind of close.
Oh, forgot. Sorry. Thank you. It's dry. Okay, so we need to graph this. We want to solve graphically. We want to figure out where this crosses the x-axis. So, here we go. Same steps as yesterday. We're going to graph this. So, you're doing it a different method. They asked us to do this graphically, so we're gonna do this graphically right now, okay?
Is that A a part
But there is another method.
Okay, I was really confused.
Yeah, no, I put that parenthesis there. So let's graph. So the first thing we do, what's the first thing we do? A, B, C. This is like yesterday. So we have A is 1. There is no X term, so what's B? 0. And C is -16. So when there's no X term, our B is 0. So the second thing we're going to do is the negative B over 2A. So X equals, what's negative? So we're going to have negative B over 2 times 1. Well, Wait a minute. Negative 0.
That's 0.
Yeah, 0 over... What's 0 over 2? 0. We have nothing. 0. We have 0 of 2 pieces. So our x part is 0. So now, how are we going to get the other part of our vertex? Put in 0 for x. So 0 squared minus 16.
Wouldn't that make it negative 16?
Mm-hmm.
Minus 16.
Mm-hmm.
That means we're way
Bless you.
over.
Down.
Down.
Bless you.
Oh, it's a Y, okay.
Is that okay? Hmm?
Negative 0?
It's just 0. So what's our axis of symmetry is, axis. X equals 0. Our vertex, 0, negative 16. Right? Let's graph this. Now, on these grids, we only have 12 little lines. So what are we going to count by? We're going to count by 2s.
Bro, we can move the origin out.
Oh, you could do that, actually. That was a really good idea. I never thought about that, Malin. Let's do that. Okay? Malin had a really good idea. No, it's not confusing. There's only we only go down to 12. Shh. We only go down 12, but we need to get down to 16, right? So Malin's like, well, why don't we just move the axis up? What do you mean it's confusing? I'm just gonna draw a new. It's not even that dark. Are you kidding me? You can't. Oh, I just moved it up. No, I'm not kidding you. Then darken in both of them. I don't even notice the darker red line.
Wait. So why did we move up there?
Because we need to go down 16,
Oh.
but we can only go down 12 the way it is. So instead of counting by a different number, I know. Malin, thank you. I learned something today. I appreciate that. So now we can do this. Way easier than what I was going to do. Hallelujah, right? So, 0, negative 16. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right there. Woo! Way down there, right? Now, the A value was 1. So if I go up 1 over 1 this way, I also have to, axis of symmetry, I also have to go over here. And we should probably pick one more point so we have a pretty good graph. 4? I like 4. And we're going to let x equal 4. So put a 4 in, so 4 squared minus 16. Nick, shh. What's 4 squared? What's 16 minus 16? So if there's right here, we also have to go right there. And guess what? Nick picked the value that is our 0. So graphically, we're good. Have we done anything really different yet? No, we haven't. Hey. The question they're asking, though, is they want to know when is the graph equal to 0. We want to know when it crosses the x-axis. So it crosses right here, and it crosses right there. So that's when x equals, what did we just find this one was? 4. And also when x equals what was it? Negative 4. That's the solution. Kind of cool, huh? I like it.
Made a face this way.
It is kind of a face, huh?
It has ears. It could be, what are they called? They have long.
Dinosaur?
Yeah.
I have no idea. Okay. We got 2 more examples. Maybe 3 more examples we're gonna do. We're gonna do 3.
Feel pretty good with it.
We're not gonna do graphic. We're done with no more graphing examples.
Cool.
because it's the continuation of yesterday. What we're gonna look at, remember how I said we're gonna learn 2 ways today? We just did graphically. Now we're gonna do square roots. Okay? So example 2. You cannot see because I've zoomed way in. There it is. So example 2. So we're going to learn how to solve this algebraically because that is not going to be a very fun one to do graphically. No. So.
Wait, how'd you say algebraic?
Algebraically?
Is that a word?
Yes.
Okay.
So when they ask you to use the square root method, here's what they want us to do. They want us to solve for x. So we're going to isolate x. So what are we going to move first?
75.
The 75. How are we going to move that 75?
Add it.
Good. We're going to add 75. So we have 3x squared. In 0 plus 75? 75. Still trying to get x by itself.
I was gonna divide 3.
Divide by 3. What's 75 divided by 3? 25. Now, we need to undo a square. Does anybody know how to undo a square?
You find the square root.
Square root. Not divide by itself. You're going to take the square root of it.
So it'd be 5.
Careful. There's one little catch with this, okay? When you take the square root, you always get a plus or a minus as your answer. I'll show you why in a second. Just believe in me right now, okay? To figure out what the square root of 25 is, what times what is 25? 5. The square root means you need 2 of the same number to equal 1 outside of the square root. It's like in order to leave the house, he has to have a partner. Okay? So do the 5s have a partner? Yep, so they get to leave the house. And now they're outside. Nope, they can stay.
So it could be either positive or negative.
And I'm gonna show you why. No, it's both. And here's what's happening graphically. Let's have this conversation. This is a good one. Graphically, what's happening is it went like this. How many times did it cross? 2. It crossed at -5 and it crossed at +5. If you have a different not a quadratic function, a cubic function. No, we're stopping at quadratics. So, here's why it's plus or minus. If I want to go back and I want to go to x squared, if I squared both, oops, that's a 2. If I squared both sides, this is x squared equals 25. But what if I square this? X squared equals negative times a negative is a. You get back to the same place. That's why you have both answers. And graphically, you have both answers because it happened twice. You cross the x-axis 2 times. So whenever you take the square root of both sides, you have to write plus or minus. I like it better than graphing, actually.
Well, if it works out, 'cause you can always do
That
that.
one is
Yeah, you can always, which is why there's other methods that we'll learn later.
This is why we get calculators.
Yes. But the calculator won't tell you plus or minus. You gotta know plus or minus. That's oh, yours will. If you take the square root of both sides, it'll give you a plus minus in front. Then you were lucky.
What if it doesn't reach the line? What would the answer be?
If it looks like this, that's a no solution. And you would write no solution. No, if it's below, if it goes like this, it's always going to cross it twice. Oh, if it was upside down? Yeah, then it would be no solution. If it doesn't cross the x-axis, no solution. Let's do another one. Example 3. Okay, so we have m squared minus 36 equals 0. We want to use the square root method. So we need to get the m squared all by himself. Add 36 to both sides. So m squared equals 36. Now square it. Now remember, we took the square root of both sides. Oh, thank you. So we took the square root of both sides. So that means we need a plus or a minus. 36 is what times what? 6 times 6. Do the 6's have a partner? That means they get to go outside. Those are your two answers. That's your answer. You're done.
So we don't have to do all the rest of that part that you showed us?
Wait, so if it doesn't have a buddy, it's no solution?
You would leave it underneath. I don't think they're gonna do that to you. No, they're gonna give you nice ones. Ooh, there is one that looks a little tricky. Let me do one with you, okay? Of a little trickier one. So let's do this one. So 64b squared equals 16. So we're trying to get b squared by itself. So what do we need to do?
You need to divide 64.
Divide by 64. So b squared. See, this one's a little trickier. Here's what I would be willing to let you do. I'd be willing to let you use your calculator. So on these kind, what's 16 divided by 64? Use your calculator. 16 divided by 64. Use a calculator. Tell me. 0.25. And now what do we need to do? Now we got to square root that. So most calculators, even your iPhone calculators, if you tilt it sideways, it'll let you do square roots, right? The one thing most calculators won't tell you is when you do this, when you take the square root, it's plus or minus. So what's the square root of 0.25? Not 0.05, it's just 0.5. It's a little tricky. A little bit tricky on that one. Okay, we have one more example. That was I saw that and it might be kind of scary. So, one more. Take the pass. Okay, so the last one is a story problem. So I need you to look on page 582 for me, please. The problem 3. Choosing a reasonable solution. So it says an aquarium is designing a new exhibit to showcase tropical fish. And they give you a blueprint, right? And it looks like a tank, yes? Oh, not my best work, but that's okay. So they tell us that the height is 3 feet. They tell us that this is the length and that's the width. Yeah? And, oh, what else do they tell us? The length is twice the width. So the length is, so instead of length, I'm going to think of it as 2W. I knew where you were going with that. Because it's twice the width. Do you see where I got that?
Yes.
It's in the story? Okay. Then they tell us the volume of the tank is 420 feet cubed. How do we find the volume of a rectangular prism? Let me remember. Length times width times height. So the volume, so 420 equals our length, which is 2W, times our width, and what's the height of this thing? 3. So we're going to simplify the right-hand side. Are there any questions where I came up with those numbers and letters and combinations thereof? Okay. So on this side, we can multiply because it's all multiplication. What's 2 times 3? 6. And W times W is W squared. Can we find the width of this thing? Yeah. What are we going to do? Divide by 6. 70. And then what? How do we get rid of that square?
Wait, is there?
I'm going to show you what I want from you. How do we get rid of the square? Square root. Plus or minus. Now, the square root of 70 isn't nice, so figure out what this is in your calculator as a decimal, okay? So square root of 70 in your calculator. You should get 8 point something.
8.3666.
So let's just round it to 4. We'll round it up to 8.4. Now, we're talking about an actual length of a dimension. So I have 2 answers, but one of them doesn't make sense because we're actually talking about actually measuring something out. Here's my 2 answers. Which one does not make sense?
Where the thing is, the plus and
Which one? Because that's not, we either have plus 8.4 or negative 8.4. The negative 8.4 makes no sense in a story problem. So our width is going to be 8.4. I think we're in feet.
And then the length is just double that.
The length would be double that. Would be 16.8 feet. So when you're talking about a story problem, you got to think about which answer makes sense. So that's the only weirdness with that. Okay.
homework time.
Homework time. It's listed on